So we have finally been able to go through all the basics that we need to understand what is going on in the evaluation of determinants. Okay, so we're going to apply our knowledge on the formal definition of the determinant that says that it is the value you get when you evaluate the matrix along a particular row or column, and that is mainly termed as the Laplace expansion. Okay, so let's read the question together. You say evaluate the determinant of the given matrix by expanding along a row of your choice. Okay, so I would also want you to choose your own row or column, and then you evaluate it together with what I will get and compare answers. So the question here is that did you get the same answer? We would know when we start working on that. Okay, so now we have a matrix, a 2 by 2 matrix, and want to find the determinant first along the row 1. And then if you remember, we said that the determinant with the expansion along a particular row or column is the determinant is equal to, or maybe that of A is equal to some summation, right, along the particular maybe row you want to talk about. Maybe if it is column or row, but let's say I equals 1 to n, depending on your I, whether the I is the column you're talking about or the row you're talking about. And then you have some Aij, right, and then times, or maybe little ones. So let me write it that way. Little cofactor Aij. Okay, I'll explain this to you in a minute. So what this means is that if I choose to go along the first row, then what I'm going to get is the first row, the entries I have in that row. Okay, so ideally it's supposed to be A sub I. That is, this A's are the entries you have in the first row. So in the first row I have 2 in it. Okay, so the summation is going to start from I, starting from 1 to 2, because this is a square matrix. Okay, so what I wrote for the n is the general term, but like I said, these Aij's are the entries you have in the row. So if I'm going along the first row, then I'm looking at these 2 elements, so 2 and 4. So 2 times the cofactor AI. So what is 2? 2 is at the point A11 is equal to 2, right? It's at the point column 1, row 1. So the cofactor is given by -1 to the power 1 plus 1. That is the sum of the I and j component times the determinant you get after deleting the I and j rows. So you have 1 1 for both I and j. So you delete column 1 and row 1, and then the matrix that will be left is a matrix with the only entry 6, right? Plus I'm going through the row 1, so the next value there is 4, and then I have -1 to the power what? 4 is at entry 1 2, that is row 1 column 2, right? Times the determinant of the matrix when you cancel row 1 and then column 2, right? So that matrix will be left as -1. And then we use the properties of determinant. -1 to the power 2, 1 plus 1 is 2, right? So -1 to the power 2 is 1, so I have 2 here. Determinant of a single value is the value itself, and then -1 to the power 3 here, because you're getting it 1 to the power 1 plus 2, which is 3, so you get -1 times 4, that is -4, and then times the determinant of -1, which is still -1. So this is going to be 12 plus 4, which is 16. Right, so when I go along the first row, I have 16. Now along the column 1, same thing. I just go through this side, so I have 2 times -1 to the power. What is the position of 2 is 1 1 entry, 1 plus 1 times the determinant when you delete column 1 and row 1, because we are at the point 2, which is A11, right? So you delete row 1, column 1, and you'll be left with 6. So I'm going to have determinant of the matrix 6, then plus the next entry there is -1 times -1 to the power what? That -1 entry here is at the point 2, 1. So you're going to have 2 plus 1 times the determinant when you delete row 2 and then column 1. And that is going to give you 4. The matrix 4, right? And so you're going to get -1 to the power 2 is 1. So you have 2 times 6. Then -1 here, you have a -1 to the power 3, and that is -1 times -1. You're going to get +1 times 4, and then this should give you 16. So whichever way you go through it, you should get the same value. That is the whole thing here. Yeah. So to answer the question, did you get the same result? Yes, we got the same result. Now let's pick a very big matrix, an example like 3 by 3 matrix. And first go along the the row 2. So I'm going to go along this row. So what it means is I'm going to pick -4 times -1 to the power 4 is at the entry row 2 and then column 1, right? So this is column 1. So I'm going to add 2 plus 1 times the determinant of deleting row 2 and then deleting column 1. And I'm going to have the determinant of the matrix 2, 3, -8, 9. Plus, when I pick the next value, that is 5 times -1 to the power. 5 is at a position 2, 2. So 2 plus 2 times the determinant of the matrix when I cancel or when I cross these. And I'll be left with 1, 3, 7, 9. Right? And then, sorry, I don't know why, but 1, 3, 7, 9, and plus 6, -1 to the power row 2, because 6 is at a position row 2, column 3. Times the determinant of what will be left here is 1, 2, 7, -8. You have to cancel row 2 and then this guy, right? So, but we have learned in one of our lessons that so you're going to have -4 first into -1, because -1 to the power 3 you're going to give you -1. And then the determinant of a 2 by 2 matrix, we've learned in one of our lessons that this is just the product of these two minus the product of these two, and that really happened in our previous one. If you look at it very carefully, this was 2 times 6 minus 4 times -1, and that's the same thing as 2 times 6 minus the product of these two. So it also happened in this same as well, right? So when you use that, that's the general definition, and then this determinant will be 2 times 9 minus 3 times -8, and that is going to give you 3 times -8 is, so I have 2, 9, 18 minus 3 times -8, so that is plus 24, and then plus 5 into determinant of that, so 9 minus 21, then plus 6 into -1, because -1 to the power 5 will give you -1. Determinant of this guy is -8 minus 14, and when you sum everything, you're going to get 240. So along the column 3, we should get the same thing, and I'm claiming that indeed if you do that, you're going to get 240. So the first thing is you pick 3 times -1 to the power 3 is at a position column row 1, column 3, so you're going to have 1 plus 3, and the determinant of when you cancel everything as column row 1 and then column 3, so you're going to have the determinant of -4, 5, 7, -8 plus the rest. Okay, so that is your task to do, and I'm telling you that when you go through the whole thing, through all these elements, so I'm done with the 3, so you have to take the 6, do the same thing, and 9, do the same thing, and you should get 240. All right. You have a fastest way to solve a 3 by 3 matrix, the determinant of it, and it's a very tricky one, or a very fast one, which I can say is a trick. Okay, so what you're going to do is the same matrix that we picked, First, rewrite the first column, attach to it like this: 1, -4, 7, and then you write the second column: 2, 5, -8, and that is it. And now the determinant is going to be the product of these diagonals, right? When you multiply them, so I'm going to have 1 times 5 plus times 9, the product of them, plus 2 times 6 times 7 plus 3 times -4 times -8. So what I've done here is the product of these, right? And then the next thing to do is to find the product of these guys as well. This, that, and that. Okay, so then minus the first product is going to be 7 times 5 times 3, then minus again -8 times 6 times 1, and minus again 9 times -4 times 2. And when you do this, 5 times 9 is 45, so I'm going to write 45 here. The next one is plus 84, I guess, plus 96, and then with the other one you're going to have minus 7 times 3 times 5 is 105, minus again I'm sorry, I want to erase this. Okay, so 105, then minus again the product of -8, 6, and 1 is -48, right? So you're going to have -48, and minus again -72, I guess. Yeah, so when you sum these things, you're actually going to get 240, and that should be your determinant. So that is a very fast way to find the determinant of a 3x3 matrix without going through this cofactor expansion. But these are actually when you are being asked, or maybe your instructor or your lecturer asks you to go through a particular column. So like I said, you can also choose to go through this column, and that should give you the same value. All right, 240. All right, so you're gonna go to other aspect of determinants as well. I mean, the properties of some determinants, some special matrices, and their determinants in our next lesson. Stay tuned.